Flux 2 Klein is now open source, lightning-fast 1-second image generation. AI image generation has taken another step toward real-time drawing, and it's not just fast, it supports image editing, local modifications, and fine detail adjustments with almost no need to start over, unlike many other models. In this video, I'll use the official workflow as the base in ComfyUI, show you the setup step by step, and break down Flux 2 Klein's local performance, where the speed advantage comes from, and which settings determine the final image quality. If you want to turn AI image generation into a truly high-efficiency tool, don't miss this one. Without further ado, let's jump straight into today's content.
Next, let's look at what types of Flux 2 Klein models have been open-sourced and summarize them. First, on Hugging Face, search Klein. You'll find Black Forest Labs' official account and its repositories. Click into any one of them and go to the official repo homepage. Base versus distilled. If the repository name includes base, that means it's the full model, not distilled and not internally compressed. This is mainly intended for training LoRa models, meaning large model fine-tuning. So if you're using it in ComfyUI, I recommend using the models without base in the name. FP8 quantized. If the repo name ends with FP8, that means it's an FP8 quantized version. Compared to the non-quantized model, it's about half the size, and VRAM usage will decrease accordingly. NVFP4 quantized. Then, NVFP4 is a 4-bit quantized model, even smaller than FP8. The NV prefix indicates a newer quantization type, optimized for RTX 50 series and 40 series GPUs. It performs especially well on 50 series, and speed may improve. So, if you have a 50 series GPU, this model is recommended. Smaller size, lower VRAM usage, and faster runtime. And if you see NVFP4 base, it's the same idea, but it's the base model version. Finally, Flux 2 Klein 9B, without quantization, is the standard distilled model. So, that's the complete overview of all 12 repositories. They're basically different combinations of quantized versus non-quantized, 4B versus 9B, distilled versus non-distilled, base. I'll put the download link in the description as usual, so you can download it as well. Put the file at model/diffusion models. Now, let's talk about the clip text encoder. Follow the link in the description and download either Qwen Free 8B or 4B, depending on what you need. If you're on low VRAM, I recommend downloading the 4B version. Place it under models/text encoders. For the VAE, we'll use the same one as Flux 2 and place it under models/VAE. Once that's done, we can load the official workflow. To generate and edit images smoothly inside ComfyUI, you should update ComfyUI to the latest version first. If you're using the portable package, there's an update script inside the portable folder. Make sure your internet connection is working, then double-click Update ComfyUI.bat. After it finishes, ComfyUI will automatically pull the latest version from GitHub, and it will also handle the environment packages for you. Those packages include front-end packages, workflow templates, and other required dependencies. Important notice, if you can't run the workflow or you get loading errors, it's usually because you didn't update using these steps, so keep that in mind. To avoid those errors, I'm using the official workflow as the demo, so everyone can run it, and it's easier for me too. After the update is done, double-click Run NVIDIA GPU.bat to start ComfyUI. After you update and reopen ComfyUI, click the logo in the top left corner. Then click Browse Templates. Under Image, you can find the Flux 2 Klein workflows. Officially, they provide 5 workflows, mainly for Flux 2 Klein 4B. Some official workflows include group nodes. If you open the groups, the internal connections are actually very clear. I simplified things slightly and prepared about 3 workflows to demonstrate. First is the Flux 2 Klein text-to-image workflow. Flux 2 Klein is split into 4B and 9B, and each has a fixed pairing. For the 4B model, diffusion model, use Klein 4B. Text encoder, use Qwen 3 4B. VAE is the same Flux 2 VAE.
For low VRAM users, Klein 4B is the best option you can use. If you're aiming for higher quality, then Klein 9B is the better choice. You must match them correctly. If you use the wrong text encoder, ComfyUI will throw an error. This demo workflow uses 9B. You can see it doesn't include base, so it's a distilled model. Because it's 9B, we use the Qwen 3 8B text encoder. Type is set to Flux 2, and the VAE is Flux 2 VAE. Now click Run. It takes about 20 seconds to complete a text-to-image generation with 9B. If we switch to 4B, we must also replace the text encoder. If you don't, you'll get an error. If you see Sample Custom Advanced Error, Mat1 and Mat2 shapes cannot be multiplied, that usually means your clip/text encoder and model are incompatible. For your information, 4B takes about 7 seconds per generation, and 9B takes about 20 seconds per generation. 4B's faster, but the quality can be slightly worse than 9B. It takes about 6 minutes to load the model, so please be patient. After the model is loaded, enter your prompt and generate the image. That's the text-to-image workflow. Simple as that. Next, let's look at the single image editing workflow. Flux 2 Klein supports single image editing, multi-image editing. The workflow is basically load model, 3 modules, enter the editing instruction, sampler, output result. You usually don't need to change much, but if you insist on using the base non-distilled model, set CFG to 4 and set sampling steps in the Flux 2 schedule to 20. That's the key difference. Here I'm using an empty apartment photo, and the prompt is, based on image 1, generate a modern interior renovation result image. The layout stays mostly the same, and it adds furniture and interior design elements. In my opinion, Flux 2 Klein 9B's editing ability is very strong, one of the top-tier editors right now. To convert it into multi-image editing, we mainly use reference conditioning. Before that, there's a node called Image Scale to Total Pixel. It adjusts resolution based on total pixel count. It does not change the aspect ratio. Example, original image is 1280 by 852, or around 1.1 million pixels. If the pixel target is 1 million, it becomes around 1248 by 832. If you set the pixel target to 1.5 million, it becomes around 1536 by 1008. After scaling, it goes into reference conditioning, which passes image information into the model for editing. How to add a second reference image? Hold Alt and duplicate the reference conditioning group node. Chain positive and negative prompts. Send the final output into the CFG guider. Upload the second image and connect the VAE. Now it becomes a 2-image edit workflow. Example prompt, place the sofa from image 2 into the room in image 1 without changing the layout structure of image 1. The result, layout stays consistent. Lighting direction remains correct. The sofa looks very similar. Floor shadows also match very well. Let's talk about generation time. Each additional reference node increases generation time significantly. Single image editing might take 7 seconds, 2-image editing 10 seconds, 3-image editing 14 seconds, 4-image editing 18 seconds, and so on. Also, I recommend scaling image 2 to around 1 million pixels as well. Flux 2 Klein tends to work best around the 1024 by 1024 range. If the uploaded image is extremely large, like 5000 by 5000, runtime can increase a lot. Flux 2 Klein also supports precise edits using Inpainting. In this example, I describe what I want to change inside the image using the Clip Text Encode node. Example prompts. Keep the girl's hat while removing the boy's hat. A precise prompt allows controlled local editing without damaging the rest of the image. If you simply prompt, remove the boy's hat, you may see both the boy's and the girl's hats removed, so keep that in mind. One of my viewers asked whether it's possible to reduce image size without losing too much quality. I'm not sure which node you're using, but I'll use an official node as an example. Here, I'm loading a 1.5 megapixel image. If you use image scale to total pixels, Set the upscale method to nearest exact, and set the target to 1 megapixel, you'll likely see blurry edges. The result gets even worse if you go down to 0.5 megapixels. To improve this, try switching the upscale method to Lanczos. When downscaling to 1 megapixel or even 0.5 megapixels, the result looks noticeably better compared to nearest exact. What do you think? Let me know if this solves your problem. If you want to do outpainting, remove the inpainting mask. Enable the external canvas pad image for outpainting. Connect the mask node to Draw Mask on Image. Expand the canvas and fill the new area with a color, for example, green. Your prompt can be very simple, such as remove the green area. The model will naturally extend the image into that region. If you want better color consistency with the original image, you can optionally add a color match node. Totally up to you. You can also be more specific. For example, in the green area, add blah blah blah, keep blah 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 unchanged. Yes, this still requires re-rolling sometimes, and that's normal. In practice, the simplest prompt, remove the green area, has the highest success rate. One small tip, you can pair Flux 2 Klein with ControlNet for stronger structure control. For example, pose, depth, lineart, or composition locking. This helps when you need strict consistency and don't want the model to freestyle too much. That said, Flux 2 Klein is already strong enough to handle most tasks on its own, so feel free to experiment with it if you want. That's it for today's video. Recently, I felt that doing the same setup routine for every new AI model release is a bit exhausting and honestly very boring. There's nothing really motivating me to keep making new tutorials and repeating the same steps over and over again. I believe that if you've been watching my videos, you already know how to set everything up yourself, especially for low VRAM setups. Throughout this learning journey, I feel like there isn't much left for me to share, so I think it's time to move on to the next chapter. If you've watched until this point, I want to say thank you to all of you who have followed my learning journey. It's time for me to do something different, something more meaningful to me, and something that makes me happy. All right, thanks for watching, and I'll see you in the next video.